Picture this. It's 1989, and a construction foreman in Wyoming just watched his brand-new Ford F-350 with the 460 big block get pulled off the job site on a flathead. Third engine failure in 18 months. Meanwhile, the beat-up Dodge, with the Cummins diesel that everyone mocked when it showed up, still running after 400,000 miles. That Dodge owner had a secret, a modification so simple, so cheap, and so effective that it would eventually force Detroit to completely rethink everything they knew about truck engines. This is the story of how diesel truck owners discovered they could transform their engines with nothing more than a screwdriver, some basic tools, and about $200 worth of parts. While the Big Three were pouring billions into developing new gas V8s that would fail spectacularly under real work conditions, a bunch of farmers, mechanics, and weekend warriors were quietly creating trucks that could outpull, outlast, and outperform anything Detroit was building, and they were doing it in their driveways. The year was 1989, and the American truck market was about to witness its biggest disruption since the introduction of the V8. Dodge, desperate and nearly bankrupt, had just made a gamble that industry experts called suicidal. They stuffed a Cummins 5.9-liter inline-six turbo diesel into their Ram pickup. Ford and Chevy executives literally laughed. A commercial engine in a consumer truck? An inline-six competing against V8s? The automotive press was equally skeptical. Car and Driver called it an answer to a question nobody asked. But here's what those executives and journalists didn't understand. Out in the real world, where trucks actually worked for a living, gas V8s were failing at an alarming rate. The Ford 460 big block, pride of the Blue Oval, was eating camshafts like candy when asked to tow heavy loads day after day. The Chevy 454, that legendary big block that powered everything from Corvettes to motorhomes, was spinning bearings and dropping valves when subjected to continuous high-load operation. These weren't isolated failures. Fleet operators were seeing failure rates north of 30% within the first 100,000 miles of heavy use. The root problem was simple physics. Gas engines make power through high RPM. A Ford 460 needed to spin at 3,500 to 4,000 RPM to produce its rated 245 horsepower and 400 pound-feet of torque. But here's the thing about running any engine at high RPM under load. Heat becomes your enemy. Bearings start to break down. Oil films collapse. Valve springs fatigue. Pistons expand beyond their design tolerances. The engines were essentially destroying themselves from the inside out. Meanwhile, that Cummins 5.9 made its peak torque of 400 pound-feet at just 1,600 RPM. It could pull a loaded trailer up a mountain pass while barely breaking a sweat, turning just 2,000 RPM where a gas V8 would be screaming at 4,000. Lower RPM meant lower stress, lower heat, and exponentially longer life. The design philosophy was completely different. Where gas engines relied on frantic activity, the diesel delivered deliberate, measured force, but Dodge had artificially limited their new diesel. The engine, as delivered from Cummins for commercial applications, was capable of far more than what showed up in the Ram. Dodge, worried about drivetrain warranties and wanting to protect their gas engine sales, had detuned it significantly. The injection pump was turned down. The turbo was restricted. The timing was conservative. They'd essentially put a leash on a pit bull. This is where things get interesting. Within months of the first Cummins-powered Rams hitting the streets, owners started discovering something remarkable. The Bosch VE injection pump that fed fuel to the engine had a simple adjustment screw under a tamper-proof cap. Pop that cap off, turn the screw, and suddenly you had more fuel. More fuel meant more power, a lot more power. The modification was laughably simple. Remove one small cap. Turn an Allen screw clockwise about 3 turns. Maybe adjust the star wheel behind it for smoke control. Total time? About 10 minutes. Total cost? Nothing if you already own the tools. The results? Extraordinary. Owners were seeing torque jump from 400 to 500 pound-feet. Horsepower climbed from 160 to over 200, and unlike gas engine modifications that typically shortened engine life, this seemed to make the engines run better. But wait, there's more. The diesel tuning community quickly discovered that the Cummins responded to modifications in ways that defied conventional automotive wisdom. A simple fuel plate modification, literally a small piece of metal that changed the injection pump's fuel curve, could add another 75 horsepower. Total cost? About $20 if you bought one, free if you made your own from scrap metal. The transformation was dramatic. A stock 1989 Dodge Cummins produced 160 horsepower and 400 pound-feet of torque. With basic pump modifications that any shade tree mechanic could perform in an afternoon, that same engine was putting out 250 horsepower and 600 pound-feet of torque. No internal modifications, no expensive parts, just fuel delivery adjustments. The gas V8 crowd was skeptical at first. How could such simple modifications yield such massive gains? The answer lay in the fundamental difference between diesel and gasoline combustion. A gas engine is limited by detonation. Too much fuel and air under too much pressure, and the mixture explodes rather than burns, destroying pistons in milliseconds. Diesels don't have that limitation. They compression ignite their fuel, and adding more fuel simply means more power, as long as you can keep temperatures under control. And here's where it gets really interesting. These modified diesels weren't just making more power, they were maintaining it under conditions that would kill gas engines. A modified Cummins could pull a 15,000-pound trailer up a 6% grade for hours at wide-open throttle. Try that with any gas V8 of the era, and you'd be calling for a tow truck within minutes. Let me put that in perspective. Testing by independent dyno shops showed that a modified first-generation Cummins could maintain 90% of its rated power continuously for 24 hours straight. The Ford 460, it would lose 40% of its power within the first hour of continuous high-load operation due to heat soak. The Chevy 454? Even worse, some examples were down 50% after just 30 minutes. The secret sauce was the diesel's compression ignition system combined with direct mechanical injection. The Bosch VE pump was a mechanical marvel, a rotary pump that could deliver precisely metered fuel at pressures exceeding 15,000 psi. It was controlled by springs, weights, and levers, not computers. This meant it was infinitely adjustable and completely reliable. No sensors to fail, no computers to glitch. Just precise German engineering that would run forever if you kept it fed with clean fuel. The modification process became an art form. Enthusiasts developed increasingly sophisticated techniques. The AFC, air fuel control, spring modification, allowed the pump to deliver more fuel at low boost, improving throttle response. The governor spring swap changed the engine's power curve, allowing it to rev higher and make more top-end power. Star wheel adjustments fine-tuned the smoke output, letting owners balance power with emissions. Each modification built on the others. A typical build path might start with the basic fuel screw adjustment, worth maybe 40 horsepower. Add a fuel plate for another 30, swap the governor springs for 20 more. Install a different turbo, and you're looking at another 50. Before long, owners had engines pushing 350 horsepower and 800 pound-feet of torque, from an engine that started at 160 horsepower. The automotive establishment was in denial. Detroit's engineers insisted these modifications would destroy engines. Magazine writers claimed the power numbers were fabricated. But out in the real world, the evidence was undeniable. Modified Cummins trucks were not only surviving, they were thriving. Owners were reporting 500,000 miles, 600,000 miles, even 700,000 miles on modified engines that had been worked hard their entire lives. The key was the Cummins Overbuilt design. The 5.9-liter started life as an industrial engine designed for continuous duty in generators, pumps, and commercial equipment. It had forged steel connecting rods that were massive compared to anything in automotive use. The crankshaft was forged from high-grade steel and balanced to industrial standards. The block was cast iron so thick you could bore it out multiple times. This was an engine designed to run at rated power for 10,000 hours between rebuilds. The modifications truck owners were making were still well within its design envelope. Consider the bearings alone. The main bearings in the Cummins 5.9 were designed to handle 1,000 pound-feet of torque in industrial applications. The modified trucks were making maybe 600 to 700 pound-feet. The engine was still loafing. Compare that to the Chevy 454, where the bearing surfaces were marginal even at stock power levels. Add any significant power, and bearing failure was not a question of if, but when. The cooling system told a similar story. The Cummins ran a gear-driven water pump that moved 80 gallons per minute at operating speed. It had an oil cooler the size of a small radiator. The turbocharger was water-cooled. Every system was overbuilt for automotive use because it came from industrial applications where failure meant lost money, a lot of lost money. But here's what really changed the game. These modifications weren't just for hot rodders. Working truck owners, farmers, contractors, haulers discovered that modified diesels actually saved them money. Yes, they burned more fuel when making more power, but they could pull heavier loads faster, reducing trip times. They lasted longer between rebuilds. They had better resale value. The total cost of operation was actually lower than stock trucks. The math was compelling. A stock Cummins might burn 10 gallons per hour, pulling a heavy load at 50 miles per hour. A modified version might burn 12 gallons per hour, but could maintain 65 miles per hour with the same load. The job got done faster, and in commercial applications, time is money. Plus, the modified engine would likely outlast the stock one because it wasn't working as hard relative to its capability. The diesel performance parts industry exploded. Companies like Industrial Injection, BD Diesel, and TST started producing refined versions of the shade tree modifications. A cottage industry of pump shops emerged, offering everything from mild street tunes to full race builds. What started as backyard tinkering became a multi-million-dollar industry. The big three were caught completely off guard. Ford's response was the 7.3-liter Power Stroke in 1994, a diesel designed from the start for modification. GM brought out the 6.5-liter Detroit, which proved to be a disaster, but both were playing catch-up to what Dodge and Cummins had accidentally created, a platform for affordable, reliable power. The really remarkable part? The basic fuel modifications discovered in 1989 still work today. You can still buy a first-generation Cummins, spend a few $100s on pump modifications, and have a truck that will outpull modern diesels costing 6 times as much. The simplicity and effectiveness of mechanical injection has never been equaled. Let's talk about what was actually happening inside these modified engines. When you turned up the fuel screw on the VE pump, you were increasing the maximum fuel delivery across the entire RPM range. But it wasn't linear. The pump had an internal governor that varied fuel delivery based on RPM and load. At idle, you might only see a 10% increase, but at full throttle under load, fuel delivery could jump 40% or more. This extra fuel had to go somewhere, and that somewhere was into making power. The diesel combustion process is fundamentally different from gasoline. In a gas engine, you have a precise mixture of fuel and air that ignites all at once, too much fuel, and you get detonation. In a diesel, fuel is injected into already compressed hot air. It ignites as it's injected, creating a controlled burn. Add more fuel, and you simply extend the burn duration, creating more pressure and more power. The turbocharger was key to making this work. More fuel needs more air, and the stock Hulset H1C turbo on early Cummins engines was surprisingly capable. It could support about 300 horsepower with good efficiency. Beyond that, owners would upgrade to larger turbos, but even the stock unit had plenty of headroom for basic modifications. Temperature management was critical. Diesel combustion temperatures could exceed 2,000 degrees Fahrenheit. The stock pyrometer gauge became the most watched instrument in modified trucks. Sustained temperatures over 1,200 degrees pre-turbo would start to damage components. But here's the thing, even heavily modified engines rarely saw those temperatures except under the most extreme conditions. The Cummins' efficient combustion and robust cooling system kept things under control. The injection timing modification was perhaps the most elegant. By adding or removing shims under the injection pump, you could advance or retard when fuel was injected relative to piston position. Advancing timing meant fuel started burning earlier, when the piston was still coming up. This created more cylinder pressure and more power, but also more stress and heat. Finding the sweet spot was crucial, typically about 14 to 16 degrees before top dead center for a street truck. The mechanical symphony inside a modified Cummins was beautiful in its simplicity. The pump's internal camshaft, spinning at half-engine speed, actuated plungers that created injection pressure. The governor weights flew outward with increasing RPM, modulating fuel delivery. The advanced mechanism adjusted timing based on load. It was all mechanical, all predictable, all fixable with basic tools. Compare this to what was happening in gas V8s. Electronic fuel injection was becoming standard, but it was primitive by today's standards. Oxygen sensors failed regularly, throttle position sensors would glitch, mass airflow sensors would get contaminated, and when something went wrong, you needed expensive diagnostic equipment to figure out what. The Cummins? If it wasn't running right, it was either air, fuel, or timing. Period. The reliability difference was staggering. Fleet data from the mid-1990s showed that Cummins-powered trucks had 75% fewer engine-related breakdowns than gas V8 equivalents. The mean time between failures for a Cummins was over 350,000 miles. For the Ford 460, less than 150,000 miles. For the GM 454, about 125,000 miles. But it wasn't just about longevity, it was about capability. A modified Cummins could pull loads that would literally break gas trucks. Owners were regularly towing 20,000 pounds through mountain passes. Try that with any gas V8 of the era, and you'd either overheat, over-rev, or simply not have enough power to maintain highway speeds. The torque curve told the whole story. A modified 5.9 Cummins might produce 600 pound-feet at 1,800 RPM and hold it flat to 2,500 RPM. A Chevy 454 needed to spin at 3,200 RPM to make its peak 410 pound-feet, and it fell off rapidly on either side. When you're pulling a heavy load, that low RPM torque is everything. It means less shifting, less stress, less wear, and less driver fatigue. The sound was different too. Where gas V8 screamed and strained, the Cummins rumbled with authority. That characteristic diesel clatter, especially with a straight-through exhaust, became the soundtrack of American workplaces. It was the sound of reliability, of capability, of getting the job done. The cultural impact was profound. Diesel trucks went from being oddities to being status symbols. The phrase Cummins power became synonymous with unstoppable force. Truck pulls, where modified diesels dominated, became major events. The diesel versus gas debate raged in every truck stop, job site, and farming community in America. The manufacturers eventually caught on. By the late 1990s, all three major truck makers offered powerful diesel options, but they also learned from the modification community. Power ratings crept up, injection systems became more sophisticated, turbos got larger. What started as backyard modifications became factory features. The irony is delicious. Detroit spent billions developing new gas V8s that couldn't match what shade tree mechanics were achieving with simple fuel system modifications. The entire direction of the American truck market was changed not by corporate engineers or product planners, but by regular people who needed their trucks to work harder and last longer. The safety Nazis and emission zealots eventually caught up. Modern diesels have complex emission systems that make simple modifications illegal and increasingly difficult. The days of turning a screw and gaining 50 horsepower are largely gone. But for those who remember, or those lucky enough to own these mechanical masterpieces, the golden age of diesel modification remains legendary. Think about what this story really represents. It's not just about engines or trucks. It's about American ingenuity, about regular people solving problems that billion-dollar corporations couldn't or wouldn't address. It's about mechanical sympathy and understanding trumping corporate bureaucracy and magazine rhetoric. Today, when you see a first-generation Cummins Ram on the road, you're looking at more than just an old truck. You're looking at a revolution on wheels, a machine that proved simpler was better, that mechanical was more reliable than electronic, and that sometimes the best engineering happens not in corporate labs, but in farm workshops and garage floors. These trucks have become increasingly valuable. Clean examples command premium prices. Modified ones with documented histories and proven reliability sell for more than they cost new. They've transcended transportation and become cultural artifacts, representations of an era when you could actually work on your own vehicle and make it better than the factory ever imagined. The technical legacy lives on. The principles discovered during the early days of diesel modification still apply. Modern tuners use computers instead of screwdrivers, but they're chasing the same thing: more fuel, better timing, improved airflow. The tools have changed, but the physics remain the same. The most remarkable aspect? Many of these modified trucks are still working today, still pulling trailers, still hauling loads, still embarrassing newer trucks that cost 3 times as much. They've proven that with the right foundation, a robust mechanical diesel engine, and some basic modifications, you can build something that lasts virtually forever. When historians look back at the transformation of the American truck market, they'll mark 1989 as the turning point, not because Dodge introduced a diesel pickup, but because truck owners discovered they could make that diesel better with nothing more than basic tools and mechanical knowledge. It democratized performance. It proved that sometimes the best solution is the simplest one. The Cummins diesel didn't just outsmart gas V8s. It revolutionized what Americans expected from their trucks. It showed that you could have power and reliability, performance and longevity. It proved that a well-designed mechanical system, properly modified, could outperform complex electronic systems, costing far more. So the next time you hear that distinctive diesel clatter, remember what it represents. Remember the construction foreman who got tired of blown gas engines. Remember the farmers who needed to pull heavier loads. Remember the mechanics who figured out that a simple fuel adjustment could transform a good engine into a great one. They didn't just modify trucks. They changed an industry, and they did it for about $200. What's the most impressive diesel modification you've ever seen? Have you experienced the difference between mechanical and modern electronic diesels? Drop a comment below and share your diesel stories. If you enjoyed this deep dive into one of the most important developments in automotive history, make sure to subscribe. We're just getting started exploring the engineering marvels that changed our world. Until next time, keep those turbos spooled and those injection pumps turned up.